Welcome back. We're going to be talking about one of the primary things that you'll see a lot in trigonometry class, or what you'll think about often when people mention trigonometry, and that is sine, cosine, and tangent, often written as just SIN for sine, COS for cosine, and TAN for tangent. And what this actually is, these are all numbers, and they are numbers that represent the relationships or ratios between sides in a right triangle. This is only true for right triangles, and how long those sides are. And the H, you could probably already guess what that stands for. That stands for the hypotenuse. O stands for opposite, so sine is the opposite side divided by the hypotenuse. I'll explain what opposite means in just a minute. Cosine is the adjacent side divided by the length of the hypotenuse. And finally, tangent is opposite over adjacent, and I won't talk about tangent again until later, but once you understand sine and cosine, tangent is easy. All right, so I have a triangle. I've labeled it EFG, so it doesn't have the same letters as any of the things down here. So if I was talking about angle E, the opposite side from angle E would be this side E over here. So if I'm talking about this angle, this one would be opposite. Hypotenuse is always this one, okay? And then G would be the adjacent side. So if we're going from E, this would be opposite, and this would be adjacent. And so whatever those numbers are, if this was 2 and 4, it would be 2 over 4 would be opposite over adjacent. And if this was 5, it would be, I'll make an H out here. Okay, and that's always hypotenuse. Now, if I change angles, if I start talking about from this angle, then these things change. Because then this one becomes the opposite side, because it's opposite from it. This one, adjacent, means next to. It becomes the adjacent side. Hypotenuse never changes. Hypotenuse is always there. And whenever we talk about sine, cosine, or tangent, we are never talking about, I'm talking angle F, I'm talking the right angle. We are also always picking one of these two angles, which are called complementary angles because they add up to 90. So I'm either looking it up for this one or this one, and I'll give you some specific examples now. The question is, well, kind of, why is this even important? How is this useful? Well, we've already seen kind of this already with our 45, 45, 90 triangle. We actually learned in our 45, 45, 90 triangle that whatever this one side is, I'm going to call it X. This side also has to be X. This is 45, 45, 90. And then we showed that, hey, whatever these numbers are, it turns out to be that number, square root 2, always is that. And if you can go back and watch the video again, you can plug in whatever numbers you want to for X, and you use Pythagorean theorem, you will always end up with this number once you simplify it. So with this, I could say, oh, the sine of 45 degrees is just, if I'm talking this angle, this is opposite, because sine is opposite over hypotenuse. And this SOHCAHTOA is the way that a lot of people learn how to remember this. SOHCAHTOA, you kind of have to remember the H's in there. This is just a mnemonic for remembering this. So sine is opposite, which is X, or 2, or 3, or whatever you plugged in for X, over X root 2, which would be 3 root 2, 4 root 2, whatever you plugged in for X. And when you simplify that, oh, that's just, X is divided out. So the sine of 45 is just equal to 1 over the square root of 2, or as a decimal, this is about 0.7071, I think. All right, and what that really means, that number, you're like, well, what does that matter? What does that number mean to me? What that number tells you is if you have the hypotenuse and you multiply it by this number, it will tell you how big that side is, okay? Because we know that the sine is equal to the opposite over hypotenuse. If I rearrange this, oh, that means hypotenuse times whatever the sine of that degree is. I'm going to say theta is equal to the opposite. So if I've got this number, which I do, for 45 degrees, it's 0.7071, and I multiply it times the hypotenuse length, I will always get that number. And vice versa, if I take the opposite number, whatever that is, and divide by that number, it'll tell me the hypotenuse. So what this allows us to do is, if we've got one side and we know one angle in a right triangle, we can actually figure out all the other numbers. Not just for a 45, 45, 90 triangle, but for all triangles, because these, for 45, 46, 47, 48, for all the degrees, somebody a long time ago figured out what all those relationships were and wrote them all down on the table. And in fact, now any calculator has a sine, cosine, and tangent button that will tell you what this button is, or what this number is. So if you typed in 45 and hit sine, you should get this number. If you get something different, you typed it in wrong, or you may be in radians instead of degrees, in which case you'll need to find the degree button and turn that on. But that's a nice check, is this. All right, so let's look at a different triangle now. Okay, 30, 60, 90 triangle. We've actually established what these relationships are already. I'm going to put in real numbers, but you could just put in an x. So if I pick some number, I'm going to pick something easy. That's 2. We know this one out here always being twice it, so 2 times 2 or 2 times x or whatever you want to do, but I'm going to go ahead and say 4. And this one over here always ends up being times the square root of 3. So 2 times square root of 3 or what x times square root of 3, whatever I pick for that number, that relationship always exists for any 30, 60, 90 triangle, no matter how big or how small. Whatever this number is, this is times root 3, this is double it. All right, so what's our sine? So first of all, pick an angle. Sine of 30. Sine of 30 is going to equal the opposite, which is 2, over the hypotenuse, which is 4, which is 1/2 or 0.5, okay? 0.5, okay? That will always be true, which means no matter how big my triangle is, whatever this thing is times 0.5 gives me that 2, which is kind of what we already said. But these are usually expressed as decimal numbers in trig tables, but it's 2 over 4 or 1/2. All right, so let's, what about cosine? Cosine of 30, well now that's 2 square root of 3 over 4, because that's adjacent, that's the one next to it, that's not the hypotenuse. Okay, hypotenuse is always its own thing. So 2 square root of 3 divided by 4. So that ends up being square root of 3 over 2, or when you do it as a decimal, it's about, got this written down, 8660. Normally in a trig table, they'll stop at 4 digits. Your calculator will go beyond that. All right, and what that tells you is if I have the hypotenuse and I multiply it times 0.866, it will give me that, which makes sense. This number should be a little bit smaller than that one, and if I multiply by this number less than 1, I'll get a number that's a little bit smaller. That happens to be the same as, in this case, the same as 2 times the square root of 3 is the same as 4 times 0.8660, or close. All right, so that's the sine and cosine of 30 degrees. What about for 60 degrees? All right, so for 60 degrees, sine of 60 is opposite is 2 root 3 over 4, which once again, oh, that's interesting, same number. So this basically says from this angle, if I want to find this one, I take this and multiply it times 0.8660. And the cosine of 60 degrees is, so from here, this is adjacent to the 60, but it's not the hypotenuse. Hypotenuse is always this number. And so this is going to be 0.5 or 1/2. Okay. Now notice the pattern there. And this is actually one of the standards that you're supposed to understand, is when you take the sine and cosine of one angle, when you flip around to that complementary angle, it's the same numbers but in reverse, which kind of makes sense because you're changing the relationships of which one's adjacent and which one is opposite. So it's going to change the relationship of, well, what do I multiply the hypotenuse by? And tangent basically just gives you a shortcut. Instead of using the hypotenuse, you can go straight from opposite to adjacent or from adjacent to opposite. Normal time, so I'm going to go ahead and leave it at that, and I'll put some problems out there on a link.